Production and factory settings bring their own set of hurdles for wireless connections. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. Now let me tell you, those engineers ain't looking to back down from a challenge like this, no sir. This here's where we gather round to tackle them hurdles, swap thoughts, and lend a hand. Welcome to the Industrial Wi-Fi Shop with your hosts, Scott and Jeremy.
Hello, everybody, and welcome to the Industrial Wi-Fi Shop. My name is Scott McNeil. This is episode 20, 900 megahertz or bust. With me is my partner in wireless crime, Jeremy Baker. Say hi, Jeremy.
What it do? Hello.
We've got a great show coming up where we're talking all things 900 megahertz, and we've got the guys from Esteem hanging out with us. Before we dive in, though, just a couple housekeeping things. Like we announce every show, Jeremy has some 3D printed plans for up in what is that? And Thingiverse for the Wi-Fi Lucid. And if you want to be able to go 3D print those out, the plans for those are free up there, so you can just hang it off your laptop and not have to wander around holding it like a weirdo.
Or hold it like a weirdo. That works too.
Right. And our beloved Wyco has some events coming up in October, Montreal, Canada, November 6th, Washington, D.C., and November 19th in the Netherlands. I don't even know how to pronounce that. Is it Utrecht or I don't know. Utrecht. It'll be in the show notes. If you're in the Netherlands and you're listening to this show, which that's a stretch right there. But by all means, there's a Wyco there. Go to it in November.
And send us a voice clip of how to pronounce it.
Yeah, I would like to know how to pronounce that. I don't know anybody in the Netherlands, so I don't know like who to pick up and call. WLPC in Prague is coming up in October in the Czech Republic, and that is boot camps are October 11th through the 13th, followed up by the General Conference, the 14th through the 16th. I know Melissa from WLPC is going, and a whole bunch of others are going to be there. So if you want to go to a great conference and you want to go to Europe, go check it out. WPLC, Prague, Czech Republic, October 11th through the 16th.
You said Melissa from WLPC.
No, Melissa. I'm sorry.
CWNP.
Yeah, Melissa from CWNP. It's too many acronyms, right? My brain just full of acronyms. And then Jeremy, you guys are still running the commissioning tool, correct?
Yep. So we have the ultra reliable wireless backhaul, the Cisco Curb, that commissioning tool where you can basically visualize the telemetry and capture. And we hadn't gotten any responses. So if anybody needs a copy of that to try out, if you're commissioning a system, hit us up and I'll get you a license within reason, unless there's like 50 people. Then I'll get in trouble.
Don't forget to check out our document library at theindustrialwifishop.com. Some new documents have been added. So there's multiple best practice documents and some other handy dandy sheets there to help make your job and life a little bit easier. And so, now we are going to move on with the show. This is 900 megahertz or bust. And today we have Eric and Dan from Esteem. If you guys would take a minute to intro yourselves and tell everybody a little bit about yourselves. And Esteem.
Sure. Yeah. So I guess the high level flyover is Esteem. Basically, we do all things wireless, right? So we've got multiple products at all the different frequency bands from 150 megahertz all the way up to 5.8 gigahertz. And so, we're the manufacturer, so we own all the IP, both from a software side and as well as the hardware side. So it allows us to kind of react, and we're going to get into that a little bit, further along in this of kind of this, the main product that we're going to talk about today on this. And because really in the wireless world, there's not a magic bullet, right? It's really about matching up the application with the best technology. Because at the end of the day,
That is a statement I could not agree with more, and I constantly say it. There is no one size fits all. You're
that's right.
exactly right. I'm sorry. Go ahead.
No, you're right. And so, we do a little bit of everything. And so we kind of cut our teeth. We were founded back in 1982, went public in 1984 to take it from paper to a product. So, we're coming up on 45 years, I guess, if my math is
Yeah.
correct.
Wow.
And so and that's really all we do. We don't do anything other than the wireless devices. So we kind of got into this back in the old, low band VHF days, down at the 64 megahertz type stuff. And it was really kind of everything was water, wastewater at that time, right? It's just PLCs were needing to talk to PLCs. And that's really kind of where we went. And this was at baud rates that really kind of operated at the speed of smell. You could just about see the symbols go through the air, and so as everything has really kind of progressed, the technology and different frequencies have really kind of come into play. And so that's kind of what we as a company do. Eric and I have both been involved, when I first hired on, I'm still the newbie here because I've only been here 23 years because Eric still keeps chugging away and he was here way before me.
Wow. At 23 years and you're still the FNG. That's pretty funny.
And I started, doing that within the support side. Eric and I work support. So that's another big difference is we really kind of take it from the engineering side and understand what those pain points are and say, okay, how do we solve this problem? Because it's very, like you alluded to, it's very different than the OT world and the IT world or even enterprise. They have different problems. We're dealing with different distances. We're dealing with different types of applications and time constraints. And so both Eric and I are very, steep within, kind of real world applications. And we take, you kind of take, here's what somebody is going through here, and we can apply it to here. And now we can bring it into the whole technology side of things. And so at least that's it for me. I'll let Eric kind of explain a little bit more. He can tell you he's been here forever, so he can go back to the black and white days.
Hey, thanks, Dan. I appreciate that. As Dan said, I've pretty much done a little bit of everything here in the company. I actually found the company. I was still going to school and got hired on. Was working, part-time, going to school part-time, and actually went all the way right after I got out of the service and been working with them ever since. I've done everything from bench technician work all the way into field engineering work, customer support, management of the support teams, management of the field support. So there's a little bit that we've touched every part aspect of this. One thing that Dan bring up, that is one thing that we will take a lot of pride in too, is that we all of us have a very, very deep professional wireless background. We've been doing it most of our careers, and that's the people that you're going to talk to. Honestly, when you call and talk to us, that's we're the people that are going to get on the phone. We're the ones that are going to work through these applications. So that's all that we do. We don't make a wireless product as kind of a side product. We do this, and we feel we do it pretty well.
Well, that's awesome. I've been a big 900 megahertz advocate really for a long, long time. And I first got exposed to your gear. Gosh, it was probably close to 7 years ago now when I did a project for a paper company down in Florida. And that's when I first got to get hands-on and deploy a pair of your 900 megahertz Horizon radios. And they were like magic. These guys down there just could not believe they've been trying to get these links up and running for over 2 years, and they couldn't do it through their conventional means with conventional APs and 2.4 and 5 gig. And I was able to introduce them to this, and it had everything that they needed to get done, and it was awesome. And so I've been kind of a proponent of your hardware for a long time. A little bit for our listeners about 900 megahertz in general. If you are not familiar, it is one of the ISM frequency bands, so it is unlicensed space. And as far as our channel designations, you have frequency space from 902 to 928, and 802.11 does divide it up into 2 megahertz wide channels or 1 megahertz wide channels, and Otherwise, just with standard frequency base, it's just 1 megahertz wide. Um, and then, generally with 900 megahertz, it's sub gigahertz, so you get longer distances, you get much greater object penetration. And in general, I've found better power consumption with different deployments that I have done. So even when you're looking at battery powered devices, they tend to last longer for 900 megahertz devices because it does not need as much energy. And it's pretty awesome. That being said, when looking at your guys' stuff, you guys kind of have a unique structure to it, and you have everything's kind of proprietary. How does without like revealing obvious secret sauce recipes, how does your stuff work, and how are you utilizing 900 megahertz in general?
Yeah, so I think probably a good way to kind of look at this, and you led into it real well. 900 typically gives us better distance, better range, better penetration into a lot of these uglier environments. Whether that be an indoor application or outdoor, and you're dealing with trees and vegetation. And traditionally it's always been kind of that frequency hopping, spread spectrum type of a thing, and which worked very well. And as things have really kind of ramped up, especially in the last let's call it 10 to 15 years, is the applications are much more, I guess, data heavy. They need
Totally
faster
agree.
times. They need a lot more bandwidth to it. And so we started getting a lot of questions and a lot of calls from customers that says, we love the ability of Wi-Fi and how much speed it can provide, but we need 900 megahertz in order to get to where we need it to go. As well as we don't want to be on, let's call it an IEEE type or an open standard like a Wi-Fi band from a security standpoint. So we continue to keep getting these questions like, well, why don't we blend the two, right? Why don't we make a 900 megahertz radio running at that frequency, but we're going to use the modulation that you use in like a 2.4 system, right? So these wide bands, it's to kind of geek it up, it's uses what they call OFDM, right? Which is an orthogonal frequency division multiplexing. The best way to think of that is it's a big freeway instead of a one-lane road that we're just shoving data down. So we can send big blocks of data. And so what we did is says, okay, we're going to take this, and of course, once you start getting into the engineering side, it's like, okay, we're going to take that modulation, but now we need to apply it at 900 megahertz so that we can get the best of both worlds. Right. And so that's really what we came up with a product called a 195 ED, which was the predecessor to the Horizon. And then we kind of basically made it a new and improved and came out with a 900 megahertz, Horizon version of that, and kind of equivalent to in the 802.11 world. It kind of think of it as running 802.11n speeds, but at 900 megahertz. Right. And so we have that wide bandwidth. Now we're still constrained a little bit because, as you mentioned, the 900 ISM band is 902 to 928. So we can only go within that. So the maximum channel width you can ever run on that thing is going to be 20 megahertz wide.
Right.
Right. So that's what really kind of dictates our maximum speed within this, because we can't do co-channel. We can't go wider than that. We can't do a 40 megahertz wide band. So we can actually run up to 20 megahertz wide channels, which gives you an RF data rate of 72 megabits. But then we can also go down skinnier. So we do 20 megahertz wide bands, we do 10 megahertz wide bands, and we do 5. And again, this is another one of those things that kind of what we were talking to at the intro. It was more a reflection of a market pull, right? It's not something we're going to go try and push. It's like, we want to do video. That's a very big thing, especially from a security standpoint, whether it's just getting a camera on a hatch for a water system. Now you're getting into things that are much higher, almost an IO type of an application, or doing controls, and they need a lot of bandwidth. Right. And then the kind of the other side of that is that it also doesn't interfere with the IT world of their 2.4 and their 5.8, kind of those enterprise systems. And so it kind of fits into those areas too, to where it can kind of cohabitate with those.
Yeah, I was
interference.
literally thinking frequency cohabitation is one of the other bonuses of using a sub gigahertz frequency.
That's right. And so we can now extend that range. And then in addition to that, now all of a sudden we can get into other things because it's not a master client relationship like a frequency hopper is. Think of it, everything is a master. And so now we can bring in things like meshing and redundant and kind of these self-healing mesh networks. And I know you want to talk about that a little bit later. But that's one of the things that now we can bring into 900 megahertz, which just didn't exist before. So now we get a much more robust and reliable network with much higher speeds to it. And then, then you get in on the secure side is not only are we encrypting the data, but it's all proprietary. And so the only thing that's going to talk to it is another one of our radios.
Yeah. So, all right, you're using OFDM, which, is a fairly common thing in the wireless universe. However, you're not using the 802.11 protocol set to go along with that with that modulation.
That's right.
Okay.
Exactly. And, and then like I say, without giving too much of the secret sauce, the other thing that is incredibly tough at 900 megahertz is there's so many different types of devices out there. So the filtering that we have to put into the radio, is enormous because you also get some of the, Verizon's got an LTE band that sits right down below that can cause problems. And you have all these consumer devices that aren't necessarily aren't designed to play nice together. They come up as constant carriers, and you get around things like C ports, and depending upon who's coming into that port, they can run. Well, I hate to say they don't care, but they don't care, and so they're booming out, super high power, and so you're contending with a lot more, I guess, a diverse type of an RF environment that you get into, and so the filtering was actually probably the tougher part. And Eric can probably, dive a little bit more into the pains that we felt on some of that, but it works fantastic now, but there's a lot of work, to make sure that we can kind of pick ourselves out of the fly pepper or out of the pepper, right?
Well, and then to kind of to dovetail into that, and it's 900 megahertz, so it's not like you can pick up your phone and kick open a Wi-Fi scanner
That's right.
and see that it's there to see if you're
Yep.
stepping on it. You really, if you want to see 900 megahertz, you got to have some kind of spec in so you can
Yep.
get out there and see if you can see structured communication. But it's unlicensed band, so it's not like you're required to do that, right?
Exactly. Yep.
But then you're absolutely right. Directly below it is licensed cell bands, and in some areas, directly above it is licensed cell bands too.
Yeah. And
Which is
license 900. Yeah.
Right.
oh, and just straight up licensed 900. Right.
Yeah.
Absolutely.
Yeah, so it's quite a dynamic world when you get into that, and so there was some challenges that that we had to overcome, and it and then you start getting into some of the other applications to where not only do you want maybe a mesh network, but now you want a mobile network that's going to go through the middle of that, and so you can put it into a client mode, very much the same as you would like a Wi-Fi client, to where this can actually handshake across the network. So if you have a maintenance vehicle or an AGV. Now all of a sudden we can do handoffs and they can move it and it's all the same radio. We just put it in a different mode of operation.
Okay. Well, since let's go ahead and dive into the mesh aspect of it because I was very curious on how you guys handle mesh in general. Within the wireless community, there's some people really like mesh, some people are really anti-mesh because of bandwidth constraints and different aspects. And let's face it, some vendors do mesh really well, and some vendors do mesh very poorly.
Yep.
And you don't know until you've paid for the equipment and you're trying to put it out there somewhere, whether or not you got a little of A or a little of B,
Yep.
And I was curious because when you start looking at some of your data sheets on how you guys handle things, I started seeing everybody's favorite network protocol in the known universe, spanning tree protocol, which is, of us network engineers, that is either your best friend or the bane of your existence.
Right.
And I was really curious how you guys are utilizing that to do auto mesh. I mean, that's interesting stuff right there.
Yeah, we use spanning tree, and whether it's just standard spanning tree protocol, rapid spanning tree, or multi spanning tree, right? There's kind of these different flavors of that, and
Yeah, I tend to avoid generic and multi and use rapid if I have to
Yep.
use it. So
Yeah, sure.
Yeah, it doesn't cause the whole network to flap or anything like that when you get into those. And so we use that to basically go out and to maintain those links and to really look and see, okay, where are we at? So there's really two ways that we can do this. And you kind of alluded to it is as controls guys, they want to have absolute control over who's talking to who. And so you can go in this and we're talking basically down at that physical and link layer, the MAC layers. And so really what we are is essentially an invisible or a transparent bridge for most applications, right? And so when we do that, you can either define this yourself, says this is my priority path, and then we go in and if you want to kind of get into the weeds, really how we can kind of control that. And because sometimes in wireless, the shortest path isn't always the best path, right?
correct.
And so what we can do is we can go in and prioritize those and essentially change the path cost of that, so that it's seeing that as a longer pathway. And we can do that, and you can go in and define this is my primary path, this is a backup path, this would be the backup to the backup path. And it's great from a control side of things, but it does take a little bit more configuration. And then we use spanning tree.
From that, all right. So using spanning, so essentially you're just going through and setting your spanning tree priorities, and it just follows. And is it the same the numeric priority that the standard spanning tree uses? The 49 or forest, whatever. Gosh, now I don't remember.
Yeah, that's all right. Sort of. How about I say sort of?
Okay.
Is on the back side, we're doing that because those values, like you alluded to, are different in spanning tree versus rapid spanning tree versus multi-spanning tree. So what we do is we try and bring the human element into this. And so we just come in and says, okay, this is a priority value of 1, a 2, a 3, a 4. And then we do the math. Then we do the math on the back side.
Okay.
Right.
And to try and make it easy. Then you can, and then the other part of that is, spanning tree is all in reference to a root bridge, right? And so rather than say, okay, you got to look at all these MAC addresses and determine which is the lowest one and put this at the root, is we can just basically click a button and set that network ID to a lower value to make it the root bridge. Then it becomes just real simple math. You can add 1 and 1 and 1, and that's a 3, and a 1 and a 1 is a 2. Now all of a sudden we know what and then we'll do the math on the backside.
Well, root bridge contention that's the basis of all your spanning tree storms and floods that shut everything down anyway. So gaining immediate control over that is priority 1.
Yeah. So then we just do, kind of a standard spanning tree beacon. And that's something also that can be configured if you want that to go out less frequently, more frequently, if you want to open it up so you have more bandwidth just for your data needs. And then it's going to react off of that. Now, the other side of that you kind of talked about is we also do something we call rapid ready, which is an auto mesh, to really kind of think of it as an ad hoc type network, to where as long as they've got the same SSID and the same encryption, they're going to go out and form their own network.
Okay.
And do that on its own. So you really have two choices. I'm going to do everything and say this is how I want it to go. Other people say I just want it to work like magic and turn it on. And so we support both. They're just two different modes of operation. And then when you get into it, and probably some of what you were talking about, the contention with spanning tree and multi-spanning tree and rapid spanning tree is I'm doing it, you're doing it on the network level, switches are doing it. So what we also have in here is that we can go in and do a spanning tree block so that the spanning tree packet won't go across the Ethernet port. The radio still maintain their own, but you're never going to see it. And at the same time, you're not transmitting your spanning tree going across this thing.
Okay.
Right. So
that's a pretty big deal there. Yeah.
Yeah. So we can shut that down. We can turn it on and off if you want to, if you want to make sure you don't have it. But we wanted to be able to say, okay, we still want to maintain that spanning tree network, but we don't want to interfere with yours, or we don't want you to interfere with us. And so we just put a block on there so it just won't go across the Ethernet port.
So what does that translate into as far as link failover times? Is that, if you just have a basic mesh up and you have two different paths and one path starts getting shaky, so it's going to fail over. What is that rough? Are we talking sub-second link transfer times?
It kind of depends upon how fast you have it. The standard itself says it has to happen in under 10 seconds. Which is the IEEE
always
standard
using
of that.
rapid.
That's right. And so it's always using that, a standard spanning tree is a 30-second failover is what it was. And so everybody hated that. So the reality is it typically takes, we'll call it 2 to 3 seconds for that to fail over. And why I say kind of vague about it, it depends upon how often you're beaconing, because it has to miss so many of these beacons to trigger that. So if you want to have it fail over much quicker, we would increase the number of beacons. So it says, okay, rather than 10 beacons per second, maybe we're going to have 20. Then all of a sudden your failover would increase, but you're going to lose a bit of bandwidth.
Right. Okay.
Right. So there's always kind of this give and take. So that's, but typically, say if everything just out of the box and you're just running a ping across this thing, it'll basically self-heal before you even notice that there's a ping missing.
Okay.
Most time and that's a 5-second failover. And so,
well, I mean, typically when you're using these sort of applications, you're a little more latency tolerant anyway.
That's right.
Because of distances. And so your expectations are already set that you're going to have a little bit more latency versus, a link that's 500 yards and you're using 5 gigahertz, right? So
yeah. So there's a lot that goes into that puzzle. And so we can really kind of move it, as aggressive as we want or as slow as we want. When you start getting into certain places where you have like an indoor application where you have a lot of multipathing. And that kind of brings me to another way. So we can either have these like in a standard bridge link, right? This mesh link to where it's going to be up as long as it can hear it. And what we got into it actually reacting to an application is that we can take and actually dynamically do that based upon RSSI. So if you have and this was a video application that they wanted to maintain a certain frame rate.
Okay.
Right. And so if and signal and data rate goes together, right? Just like in Wi-Fi. So if the signal drops too low, even though I can hear it, I want that to go away or shut down. So I can actually go in and change it. Says, okay, if my RSSI is below a -70, I want that to be a down link, even though it's there, right? So you can dynamically change this based upon how much signal you want. Usually it's not because of signal, but because of data rate, and they kind of jive together.
Right. Well, that's nice that you can set your own thresholds like that.
Yeah. So rather than it being, I'm hearing a packet, because usually that's the flip side is when it's a very low signal strength, and I may get a packet once every 5 seconds. All of a sudden it comes up, then goes down, comes up and goes down. Well, now we can, like you said, I can set a threshold to determine, okay, I'm going to ignore that because even though I can hear it, that's a horrible link, right? And so you can dynamically control that.
Yeah, I wish that was the case in certain other vendors, because just because you can hear it and there's a link established doesn't mean it's actually the best link for your application.
Right. And especially when you get into the older technology at standard spanning tree, when that thing failed, the entire network had to rebuild or reconverge. At least rapid spanning tree, each link is individual because it's already built this into a port table. But now all of a sudden, you have one, that's out there and it can hear it bouncing off the side of a building every so often. If the window washer is up there, well, then it comes a link up, then it goes down, then it comes up and goes down. So, that was kind of those were painful times back, but that was probably, 15 years ago.
I'm going to tell you, 15 years ago, I was working in higher ed, and I'd been on the job at this job for a month, and I didn't disable spanning tree on this one switch that I replaced, and I shut down half the campus.
Yeah,
it was awesome, and it took me 2.5 hours to recover from it, everything back up and running, and then I had my first review with my boss. So good times with spanning tree.
I've never, in my experience, taken a network down.
Oh, never
Intentionally.
Intentionally.
Yeah. And and kind of one of the cool things with this is when we get into some mobile applications with that dynamic is that we have some, a customer that does some AGV in the ag world, but they've got these, I can't really tell you a whole lot other than it's in the ag world and they're doing chemical spraying. And so when they have these things out into the fields, they may not be able to get back to that master, but now all of a sudden, because of this dynamic meshing, is everybody can use everybody else as a repeater. Because
Okay.
On day one, you may have unit 1, 3, 7, and 9 out there. And on other days, you may have others. And so what they can do, again, it's kind of like an ad hoc network, is they can basically just, it's very dynamic and flowing, and it allows that thing to, rather than just being a straight client, now it can also be, kind of think of it as that client and an access point at the same side. So you
Okay.
can,
So
so when you get into a mobile world where everything's not statically done, this is where it really kind of, and that's why we really kind of came up with this, is it's like, okay, this really is, I need to be able to ebb and flow based upon where these devices are out in these orchards, right? And so again, and so if I move from one end of that field to the next, I may not be able to talk back to where the guy that's controlling this back on the outside of the fields, but now I can talk to the one that's 3 rows over, right? That makes sense?
No, it does. I've been reading a lot about these little new technologies, weed bots. They go out and they have little lasers and they just burn weeds as they
Yep,
roll through the fields. And conceivably, they could kind of mesh themselves
yeah,
back to the primary network and really extend the range
that's
of
right.
how far they can go.
Yeah, in a mobile environment, and that's really a big one. Is, when everything is static, it's pretty easy because you could say, okay, this is how my path is. You bring mobility into it, and it is a whole different ballgame.
so
Yeah.
is this like a functionality that you guys developed kind of
Yep.
based on this coming up, or is this something that was available before and you used it in this application?
This was something we had to develop, and basically we go to our software guy and say it has to be able to do this,
That's
and
cool.
usually he rolls his eyes and at Eric or I, and then goes to work at it, and
That's good to hear though, because it's especially like in some of the environments we work with, like it's really nice when you run into a radio company or a hardware company that'll work with you and kind of help you like mold or develop features for a system, because sometimes things won't do exactly what you need, but
yeah,
they could relatively easily.
that's kind of what
So that's
I had
bonus points
mentioned.
right there.
Right. And because we write all the software, write all the drivers, is that we can really make it do just about anything we want. So if we get customer that says, because that's kind of the reality is, we can dream up all these applications, but the first time we do, then somebody says, yeah, but can it do this? Right.
And are you guys, I don't remember if this has come up yet or not, right? But are you able to pass like Profinet traffic or like SIP, or do you have any systems that you're running safety or anything over?
Safety is typically not used much just because there's zero forgiveness for a missed packet. And
Hmm.
you're never going to get 100% packet through there. And so depending upon how you're doing it, but the only thing that we don't do a lot of is safety. But you're doing SIP, we're
Yeah.
a Rockwell partner. So, I mean, they're running their stuff quite a bit across this. And then you have to get in, and a lot of it is understanding those protocols and RPI values and what works best. And we spend a lot of times with them doing the same type of testing. But safety and it just is not built well for anything that may miss a packet because it kind of cascades, and then they call you
Yeah.
and Scott in the middle of the night.
Well, what's really fun is when you get there and then you're like, what's the RPI set to? And then that person has no idea. And then when you finally get logged into it, you see they got it set to like 1 millisecond or something.
Yeah,
Yeah, it's a
And
joy.
it's like, this is not gonna work.
yeah, and everybody's set to 1 millisecond.
Hmm.
Yeah,
And what, yeah, I mean, you sit there and you try to ask them that, what kind of RPI are you guys looking at for your safety application? Oh, 1 millisecond. I'm like,
yeah,
oh,
yeah, yeah.
if there's going to be wireless involved, there's going to be a little bit more latency involved, just due to
Yep,
the nature of the beast. And then the lower that frequency, the greater the chance of some latency getting added because
that's right.
again, physics, right?
Yeah, that's right.
So,
Yeah, and that's kind of the other part, and Eric kind of talked about it. It's like, we've kind of done all this stuff before, so sometimes the answer is no, you can't do that, right?
Yeah,
right.
that is an
And
answer.
yeah, no is an answer as well. It's not always what everybody wants, but it's like, well, that's the reality of what you're getting. It's like, yeah, we'd all like to run, the speeds of 5.8 gigahertz at 42 miles, but it's like you're not gonna,
Well, I mean, I
you
think
know.
it's important to know uh, the limitations of your technology,
Yeah,
be it how everything on the amazing side, but also everything on the, well, we don't do that very well side, so
Yeah.
that really helps you guide successful deployments. Because
Yeah. And
why would you willingly go into a safety application knowing your product really wasn't designed for that and try to
mhm.
push that? Because I've dealt with vendors like that before. Oh, we can do anything and everything, and then no, they can't.
Yeah.
And
Yeah,
but
the
the
vaporware
right,
fairy tale.
yep,
Yeah. And sometimes it can be like, yeah, I need to get 20 miles into these trees up in Maine. It's like, and I want to do 5.8. It's like, you can't. So we can do that with, say, 150 megahertz, but this is going to be your speed. So, it's really kind of getting down. And that's one of the reasons why we still do all the different frequencies is because they all have a place, right?
absolutely, absolutely.
Yeah, we're not all in Florida out in the flatlands to where, the
Yeah.
highest thing is a building. We're out in Washington State, and so we contend with the mountains and the trees and and what those trees do during the summer versus the winter when they're full of
Absolutely.
water, right?
Hey,
Yep.
alligators attenuate a lot though. And sometimes there's iguanas falling from the trees.
Yeah. But anyhow, that's kind of that's really kind of the beauty of it. And then there's different modes that we can put these in. If you want just a straight bridge mode, if you want to get into, doing kind of a NAT type of a source NAT, which we call masquerading. It's all built on a Linux operating system.
I
So
was
if you
going to
want to
ask
just
that sounds very Linuxy to me.
Yep. And so, if we want to do a routing, so you can have individual subnets on each location, so you can say, okay, this subnet and this subnet and this subnet, we can do that as well. Some of it is just we get a lot of times we'll get into some little municipalities and they just want a bridge, but they have their entire city hall network going across the wireless network, and we just want to break some of that traffic up so that we're not occupying all that bandwidth, right? Again, it's all just physics. If we only have this much, you got to choose what you can get through there.
Well, I mean, you also have to really love the classic manufacturing flat network.
Yep.
Oh, sure.
Sure, we've got segmentation. We're running 42 different subnets on VLAN 1.
Yeah.
Yeah, the whole plant's on a /8 network. Don't worry.
Yeah.
It's like, oh, okay.
Yeah.
And
So
we do a lot. We know the industrial customer running into too, and that's the one thing, especially looking at the mesh network and how we, even if we go in and manually set the priority of these, that was one of the things that comes back is a very beneficial feature is the fact that it will always follow that priority. So if you've got one of, say, a main repeater site that is your primary repeater site and it were to go down, as soon as it's replaced, the network will come back and reestablish itself under that original parameters. You don't have to go reapply or redo each one of those remote links so that they know who the other mesh is. So it will
yeah.
follow that exactly as you lay it out.
Well, being deterministic is a big bonus in the industrial manufacturing world. So you want something that's going to happen predictably every
Right.
single time. I'd like to take a moment to thank our sponsor for this episode, Global Process Automation. GPA is an engineering and technology firm based in North Carolina, serving clients in industrial processing and manufacturing, focusing on solutions for industrial automation, operational technology infrastructure, industrial control systems cybersecurity, manufacturing intelligence, and analytics. For over 25 years, their clients have entrusted them with their processes to maximize their company's efficiency and obtain an optimal ROI based upon their assets while protecting their operational technology resources. GPA's mission is to automate, optimize, and secure manufacturing floors everywhere while maintaining their core values to have integrity, to continuously improve, embody their community, remain customer focused, and implement great teamwork. Thanks, and back to our show. Security wise, what are you guys packing security wise on these devices, right? So I realize there's going to be different for bridging and then different for like AP client modes, but what kind of security are you guys ranging from? Or do you even use any of the legacy stuff anymore? Or is that even an option? Or are you staying with current stuff? What you got?
Well, I've been talking a lot, so I'm going to shut up and let Eric talk because I don't want to hog the whole thing.
No,
So
no, Dan, you're doing a great job. No, actually,
Well, he is the
kind of,
new guy, right? You got to
yeah,
give
right.
him some props, right?
yeah.
To answer your question, I mean, we actually do support all the modern standard. We can actually go up to an AES 256 on the links,
Okay.
especially in the 900, because we don't have to support open clients. So we can actually set the standard, us being the client and also us being the access point of this site and that kind of a network. So we can actually run all the way up to AES 256 in there. But we do actually support the older type of encryption, all the way down into the WEPs if necessary, primarily for our own purposes, to be honest with you. The reason for that is because our current radios, our Horizon 900, actually supports all the way back to our original 195 ED. So it didn't have those security
Okay.
capabilities available at the time. So we have to be able to provide communication links and intermix with those links. Most of the new technology that goes out, of course, will be running the highest encryption levels that are on there, and we can do that. It's very easy to set those links, especially when you're doing the rapid ready links and the links that Dan was talking about. As long as you can match up the passphrase in it, they will generate the keys and start the sessions. And we're not reinventing any wheels here, but they do support this much higher ended security measures.
That's awesome. I did see in a data sheet that you guys are on in client mode. You are pushing WPA2. Are you guys doing any WPA3 at all, or is that in the works possibly, or not really concerned about it as much due to the proprietary protocols and the frequency?
A little bit of both. One of the things that we're adding onto the Horizon 900 is the ability to add in a Wi-Fi, let's call it an access point, say for things like an IoT device or a sensor, things like that. And that actually will support WPA3.
Okay.
But the current product out there is maxed out at a WPA2.
When you say you're adding an access point, I'm assuming then that's going to be what, like a little 2.4 radio
Yep.
or okay.
It's actually a 2.4/5.8.
Okay.
And it'll just be an option that you can order at the time. And because we've had people the same thing as we love the 900 to get out here, and a good use case is, hey, we've got these that are like a mobile device, say a front loader, but I need 900 to get to where it's going. But the guy that's sitting in the cab is trying to look at something on the other side with a tablet. And so they don't have an Ethernet connection into that radio, so they can be able to Wi-Fi into it to be able to also have access to it. And that's just getting rolled out now. Probably be out hopefully by the end of the year available, but it'll just be something when you order one, you say, hey, I want to add this to it, and it'll be, $200-300 to add that capability to it.
Okay. And then
That's
so really the only bandwidth restriction you'd be looking at would be your 900 megahertz backhaul for that.
More than
Exactly.
likely,
Okay.
Yep. And that's especially when you get into some of these applications is they love the 900 or we need it to get there, but you can kind of get into the whole IoT world to where you have what's going to win out in the end. You'll get a different answer anybody you talk to, right? But we know a lot of people right now are rolling out just Wi-Fi, right? Because it's what they're used to. They're using it in their house. They're, everybody without going to a proprietary. So again, we're asking us, is there any way to add Wi-Fi to it? So we actually can, and it comes up and you can add it to right into that bridge. So it's just a piece of that network. And whether that is like I say, a sensor, also you get into, tablets, a lot of guys with handhelds or they're running into, something to where, that maintenance guy I don't want to go stick my head in the middle of this machine. I just want to be able to tap into it. Right.
Yeah, we see a lot of use cases specifically with Android tablets,
Yeah.
with just heavy duty cases on them, specifically for maintenance guys as they're running around, so they can connect up, pull schematics and diagrams, so they're not having to run all the way back to their office or the control room, or they're not having to carry around large paper and worry about it getting screwed up.
Right. They've already got their thin client or thin manager system running, and now this just brings that into it. And and to be able to do on a 900 as well.
Well, in many cases, it also gives you the ability to run a mobile HMI, you
Yep.
know.
Sure.
So, and you figure controls on vehicles is not unheard of. It's actually
Nope.
fairly common, and to be able to have a wireless HMI option right there in the cab with your driver,
Yeah.
that's a pretty big deal.
Yeah. So like I say, so that's when, but that one will have the WPA3 to it as well. And so as things move forward, probably the next gen will be up to that. It, we tend to have, and Eric alluded to it, is a very long product life cycle, but we also, because we're really that manufacturer, as we try and bake in backwards compatibility. So the next generation will be backwards compatible to this one as well, because especially the industrial world, it's not necessarily the most cutting edge or moving as, and the last thing you want to do is to go tell your customer, it's like, yeah, you bought those last year and we have a new one, but yeah, you'll have to replace the whole thing. So we don't do that. We
Yeah,
we make everything backwards compatible to it. So gets you 20 to 25 years worth of use out of that technology.
that's pretty impressive.
Yeah.
And I get that for the backwards compatibility, especially. And again, this is one of those things I say ad nauseum, industry and manufacturing, easy for you to say. In general, um, especially dirty manufacturing, tends to be 10 to 15 years behind on new technology rollouts. Um, and then just basic refresh rates are double what they are in
Yeah.
enterprise. You
Yeah.
know, if you're getting a refresh rate of every 6 years, you're really, really, you're doing amazing things.
Yeah. Yeah. How often do we
Yeah, we
walk in
get
and find somewhere where we're still running an old PLC 5 out there?
yeah, we get calls on that's what I was gonna say is we get calls on those where it's like, hey, we got this thing that's been end of life for 15 years and it's still running.
Yeah.
I can't tell me how many times guys on my team have had to virtualize XP machines so that we could secure them because that is the only thing that will run the legacy equipment that particular site has deployed. And if you
Yeah.
try to move to Windows 7, it just breaks the entire application, you
Yeah.
know? So that's cool, but the other bonus to that is you're keeping backwards compatibility to your own equipment.
That's right.
It's not
Yes.
like you're trying to be backwards compatible to the wireless devices all across the universe.
No, no,
So
we're obviously more worried about our own equipment and kind of what, Eric was talking about with, there's still places that have only got 802.11b, laptops, right? That we run into that they can only run WEP 128-bit. Right. But that's the reality, and sometimes they all share one, and they've got
ugh.
a, and so it's, we're always trying to push that, but there are applications that's the max security they can do as a WEP 128. It's like, okay, well, it's better than nothing.
Yeah.
Old
And it's
wireless B handhelds, scanners.
Yeah, exactly.
Those are the dirty dogs I tend to run across.
yeah.
Yeah. And so it, and then the nice thing is when they do upgrade it, all they got to do is change the security. I mean, it's a very simple change on there, but it's important to our customer base to be able to support some of those old legacy devices.
Well, it's all about downtime and avoiding that downtime, right?
Yeah, that's right.
That's the constant fight is you don't stop the process. You got to keep going. And so if you can avoid downtime, then that's a big part of it, right?
Yeah.
For sure.
So I was
Yeah. Before I hijacked you and Eric's conversation about security, sorry.
no, it's fine. It's fine. I deployed a pair of these like we were talking pregame and I deployed a pair of these like 6 years ago. And when I did, I went ahead and got some spectrum analysis grabs of the different channel widths because I was really interested to see what that was going to look like spectrum wise. And then, with the advent of Wi-Fi Halo, 802.11 AH coming out and finally getting ratified and devices actually finally being produced and put out. Jeremy's got a couple, I've got a couple, just to lab up and test and they're just little inexpensive radios, but I wanted to see what they looked like, and I started getting some captures. I actually did a LinkedIn post not too terribly long ago and did a side-by-side comparison of your proprietary OFDM with Wi-Fi Halo, and I put a couple of those grabs in the show notes, so they'll be on the site afterwards. And it's really interesting just how similar the signatures are. as far as the structured communication is concerned. A little difference in the channel widths, because you guys are 5, 10, and 20, whereas Halo is 4, 8, and 16, I think. I'd have to go back and double check the larger one. But the Halo does have your classic Wi-Fi signature to it. And while yours is similar, you can definitely tell the structurally, as far as the Spectrum signature is concerned, there's some differences to it. But I just thought that was really cool because I'm a spec and junkie, and I'm a visual learner. I need that visual to really help my brain kind of comprehend and understand what's going on. But it's interesting that even in the grabs that I'm putting up there, that is a 5 megahertz wide channel. But when you look at the utilization, there's definitely a lot of heavy utilization all around that 5 megahertz. So
For sure.
even though it's a 5 megahertz channel, and you're looking at what's your rough throughput at a 5 megahertz channel, about 10, 15 meg, roughly 7
Yeah.
to 10,
Yeah,
right
yeah,
around
13
there.
and a half. Yeah, 13
Yeah,
and a half.
okay, there we go. It's still using you're still having a lot of utilization across that entire channel space.
Oh, sure.
But Halo is too, so it's not just and it more than likely I would think has to do with just the OFDM modulation.
Yeah.
But I just found that really interesting, and as it scales up in channel width, you obviously your utilization is getting more and more and more and spreading out and whatnot.
Right.
But I can definitely vouch for the throughput that you're getting with those, because I did some throughput testing, and I was getting close to the maximum thresholds that you guys have listed in your documentation for this stuff. And then the actual deployment that we did, I set for 10 megahertz wide channels, and I was consistently through 3/4 of a mile of dense foliage, was consistently getting anywhere from 18 to 20 meg worth of throughput.
Sure.
So that 3/4 mile link through dense foliage was supporting 2 computers, a printer, and several handheld scanners for being able to check in supply trucks in and out of a paper mill.
Mhm.
And they were having to use like a cellular modem, and so each truck check-in originally was taking 30 minutes per truck.
Oh, God.
And so the trucks were backed up down the road. They were getting harassed by the highway patrol for trucks blocking lanes. And once I got this link up and running for them, they were back down to 2 and 3 minute check-ins, and that wasn't an issue anymore.
Yeah.
But it was impressive through that kind of foliage, that type of obstruction, how I was able to evenly maintain that kind of bandwidth for the resources at that check-in gate. So it's pretty impressive, just in general. What do you guys think, just in general, just kind of your opinions on Halo as it's coming around? Do you think that could really start becoming more of a competitor in your space?
I don't know that it'll be as much a competitor, because at least I'll admit we don't know a ton about, it's still pretty new. But it's almost geared a little bit different type of an application, at least from my understanding. You can correct me if I'm wrong, because I guarantee
No,
you know more about
I
it than I do.
agree totally, because
Is
Halo, from what I've seen, doesn't have any sort of mesh capabilities at the moment. I don't know if that's coming or not.
Right.
They can
And
do all your standard Wi-Fi connections as far as like bridging and client and whatnot.
and it's typically
anything client,
it's typically for a much closer range. Really what we're brought in for is to really get out, and you mentioned the distance you're looking, but it's pretty normal for us to be in that 3, 5, 6 miles range of trying to remote, and really all we are is we're just connecting those devices, so your platform can run whatever you want across it. At least from where I've seen, where a lot of the Halo stuff is almost getting into some of the IoT world. And it's a lower power device. I mean, the idea is that you can run it on, say, battery power, and we're a full 1 watt output radio, and so it takes a lot of power to get that kind of range out of it. So it's almost an apples and oranges type of a thing. And I think what would be interesting is to kind of, and Eric and I have been talking about this in the last few days, So we looked into it is maybe it would make sense, as this matures a little bit, we're not opposed to putting a Halo receiver in that radio. So if that technology wins out, so you could bring in those Halo devices into our backhaul.
Right.
And
And then
like
backhaul it from there over that longer distance.
yeah.
That's interesting. Okay.
And so, we have had similar discussions, say with wireless HART, is kind of, but it's a pretty short range. And so they're always looking, okay, we want a wireless HART from this sensor back to where it's talking to.
Scott's ears up on that. You said wireless HART.
Yeah. But now all of a sudden they need to backhaul it back to where it's going. And that's kind of, it's kind of the same thing that why we're adding this 2.4 little module to it is service the local and then backhaul it.
Yeah, I agree with the statement that Halo is really geared more towards IoT and sensor whatnot.
Yeah, connecting a lot of clients at low throughput.
I think the big attraction to that is the fact that it can use all of the advanced 802.11 security portions to it.
Yep.
And it's a protocol that a lot of the wireless communities all of the wireless communities are already familiar with, so it makes it easier to support from that end. I could see it not so much as being a competitor to you guys, but like kind of like what you were describing, really, because it could be a value add add-on.
That's right.
Conceivably.
That's kind of how we're looking at it, is how do we, it may be the same customer, but it's not a competitor to what we're trying to solve.
Right.
And if we, it's kind of the better mousetrap thing, right? And I think as it matures, we'll get a lot of clarity of where the customers are wanting to put this in. And it's going to be, honestly, it's probably going to be discussions with like you when you're saying, okay, here's what I'm trying to do and bring this in. It's like, oh, how do we now build this, right? There's a lot of collaboration. I think that's going to have to happen with that.
What are your biggest verticals that you guys are operating in these days? Are you guys? I realize you're heavy into wastewater because that's kind of where you grew up in, so to speak.
Mm-hmm.
But what are your primary verticals these days that really are leveraging the power of 900 meg of these radios?
Eric, you want to go ahead?
Sure.
Like I say, I'll
just
shut
up.
up.
Jump in on you.
No, I realize I'm occupying way too much of the.
No, I do that all the time, and I'm waiting for Jeremy to throw something at me because I'm a talker and I tend to not shut up. So
no, we're seeing a lot of use case, of course, in the 900 is what you said. We'll call it a classic. Even all the way back into narrowband customers, that water, wastewater, we need the distance. We need to be able to cover some very difficult terrain. It fits a perfect model for that because now you've got more advanced hardware that you can apply out there, get much faster responses, but you're still able to get that distance. You're still able to get that penetration for it. We're also seeing some kind of unique verticals in there where we're getting into the agricultural markets, mining, oil and gas. Surprisingly enough, we're actually getting a lot of like AGV and factory floor applications for it. And it kind of came up before, like you were saying. I mean, people are kind of familiar with it. And that's one of the main reasons we use a lot of the terminology in the way that we set our modes up. We've got an access point mode. We've got a station mode. People understand what those actually mean. So we reuse those same terms. And because of that, now you can actually get people that are familiar, comfortable with these 802.11 networks and essentially apply in a 900 megahertz network. It's going to function identically. It's going to have the same handoffs. It's going to have the same very similar configurations for it, but now it can be pulled out of that IT world. It's in its own proprietary frequency band, its own proprietary communication, which ups your security level, and it's out of the IT space, so there's no conflict for it. So now we are actually giving the customers these applications that they want, that they're not necessarily limited just to the 802.11 world. So that is one of the key things that we're seeing that's very, very unique in that 900 megahertz space.
I think you guys too were, earlier you kind of hit at it, and it's something that we discussed with the Cisco guys on the last episode was that, getting like a stable, longer range reach out to something like a forklift and then still giving that small private area
Yeah.
of Wi-Fi for the, for a tablet or a scan gun or whatever it is. And I think that's, people are really, they have kind of weird areas that they have to get to, like, it's not, they don't necessarily need full coverage out in a lay down yard or something, but they need to run a side by side or something out there and still be able to do some work. So
Yeah.
I can definitely see that in a big plus for you guys.
In what's interesting with your question is there's almost two ways to answer it. Is we do a tremendous amount of work right now. There's a lot of people that are just upgrading their, we'll call their older 900, right? So I want to modernize, either whether it's because of speed or because brand X just doesn't exist anymore. And they're using that because they can use a lot of their existing infrastructure, antennas and cabling and everything else. And that's a little bit more of those traditional ones. And like Eric was talking about, and we start getting some of these real wild ones where you're like, I would have, you could put a gun to my head and I could never come up with the application that some of these people are doing. And it's like, yeah, it'll work perfect for that. And then they, and so we kind of have we'll call it the brownfield side and then the greenfield side, and they're
Okay.
very, very different looking. There's still some crossover there, but it's, the new and innovative stuff is truly, I mean, it's everything from rock pickers and, tomato sleds and ag work and, USA Rowing wants to have cameras out in the middle of the course when they're going up and down, these rivers and some of these things. Yeah, it's, and they just want to have this, but they want to have it on the spot. Right. And so it's that they can bring from place to place to place. And so it's fascinating really when you start. That's kind of the cool part, at least for me, and I
For sure.
speak for Eric, is because our stuff is kind of the same, but where it goes is so diverse right now. It's just going into everything from nuclear facilities to, like I say, a rock picker, that they're trying to do. And
Mhm.
and so that's what makes it fun, right? It's these different applications.
Well, I mean, it's interesting. You guys, you talk SIP, you're a Rockwell partner. What is the Jeremy, what is the Siemens
Profinet.
Profinet? Do you guys do Profinet as well?
In certain cases, um, like I say, it's we've got some different applications and some of the steel mills that are running Profinet across this.
Okay.
Um, it, like I say, the other difficult part is there's a lot of times where we have no idea what people are running across this, right? It
Sure.
comes in, I want,
That's fair.
10,
I
yeah,
mean,
yeah, I want 10 radios and, to this and, and I understand their points. Like, well, what are you doing? It's like, well, that's kind of, some of it's kind of this leading edge robotics that, we don't want to give away any, how we're solving the problem to our
we just want that
competitors, right?
transparent bridge.
And
Yeah.
some of it is honestly due to security. It's like, well, they don't want to know what frequency anybody is running where, right? And so it, uh, sometimes it gets difficult because our board of directors, same thing. It's like, well, what are some of these other applications? Like, so there's times we have no idea. The distributor doesn't want to. Does, what are they doing with it? I don't know. And it's everything from. I mean, there's packaging and everything. And you're seeing it really kind of be brought more in, as you talked about, and I don't remember if it was at the beginning of the show or just when we were kind of pre-gaming it, is wireless is just being accepted everywhere. Before it was always kind of the black magic box that,
Yep.
and that any kid in the parking lot with a stick of gum can hack, and anymore it's not. It's now a viable, solution. Sometimes it's just because it costs too much to run a piece of fiber to the other side of the building, so we're going to throw a wireless link and be up in a day.
Yeah, that's when we were pre-gaming, we were talking about that, and that's the big thing about industry in general, and manufacturing in general. And I'm excluding all of your like super high-end, super fancy like car manufacturing because all that is built on cutting edge, bleeding edge technology. But when you're looking at big ag and you're looking at oil and gas and you're looking at dirty manufacturing like pulp and paper and specialty chem,
Yep.
these guys are finally coming around and they're finally understanding that yes, wireless solutions are reliable, dependable, and they are secure, right?
Yeah.
And
Yes.
it's finally getting through uh to the decision makers that it's a sensible use of their money for reliable application processing at their plant, right?
Yeah. Yep. And some of that is, like you say, it's more accepted. And I think a lot of it is also, there's all this talk within the manufacturing of the age gap that's different. But you look at it as some of the newbies, it's like, the idea of having to wire something together is just foreign to them, right?
It is, because they live every day. All their devices are wireless. Everything at home is wireless. The only
right.
wire they have is going to their cable router or modem or fiber there in the house, and that's it.
That's right. It doesn't
Everything
scare them.
else they're linking up. So if everything at home is wireless, how come everything here can't be wireless?
Yeah, it doesn't scare them, and so
Right.
I think a lot of that is really going to continue as the aging workforce is out. All of us old farts are out of this thing, and the new gen is coming in. It's like they're just like, well, yeah, you just use wireless, right?
Yeah, it's a no-brainer. They don't even think twice about it. There's got to be a wireless fix for this.
No, yeah, you talk to them about a serial application, it's like a what?
Yeah.
But and so I think there's a lot of that's also aiding this as well. It not only is it more accepted, it's just that's what a lot of the new stuff that's just always been here, right?
Right. Absolutely.
Yeah.
Man, God, we have covered a lot of ground here today, guys. What else does Esteem have in its bag of tricks, as far as what you guys do?
Sure. We actually manufacture about 10 different radios. And as we were talking before, and unfortunately, if there was one radio that could solve everything, we'd be more than happy, because we'd have to make one radio, everything goes out the door. Fantastic. But we still cover everything back to the licensed VHF frequencies, 150 to 174. We've even got a 200 to 220 megahertz radio. We go into UHF at 450 to 470. So we're covering a lot of and giving, Ethernet interfaces into those products that were really limited to serial only applications. But we're seeing even a lot of updates for it that, hey, we haven't modernized the equipment, we haven't updated those, so we still have those radios available.
What kind of throughput are you getting on those ultra low bandwidth or ultra low frequencies?
The maximum we can do is about 50 kilobits per second.
Okay.
So I mean, it's nothing that's going to blow your hair back.
Well, no, but it's fine for serial data, right?
Sure. And if you're doing even data collection, if that's your only option that you can get out there, and you're doing even slow speed Ethernet data collection, it gets the job done. You're not going to be doing networking anything over that,
right?
But it's still it's very serviceable, and you think 900 has some great penetration. We get down to the 150 megahertz band, you can pretty much go forever.
Oh, I imagine
there's really very limited locations that it'll go. We still actually we have two different 900 megahertz products. We have the Horizon 900, which we covered a lot on. We even have the kind of lower end, what we call the Edge 900, which is a 1 megabit throughput. What's more people more classically understand them as kind of a hub and spoke network.
Okay.
And then we take that, we do actually make Wi-Fi products or Wi-Fi based products in the 2.4 and the 5.8 gigahertz, and we still have a licensed 4.9 gigahertz radio that basically follows that same high speed band, but they've been a lot of changes in that frequency band. So it's very difficult to say what's going to happen with that, but there are customers out there still utilizing that. So that's one of the things that we look at. Every application is going to be unique. That is one of the things that we kind of do bring forward, is the fact that we look at it from an application basis. How far do you need to go? What kind of speed? What environment do you look at? What are you going into the future? What's around you? And from that, we can push or pull towards those different radios and get you the best solution for it, instead of just trying to shoehorn you into something that we have available.
Jeremy was putting in some notes, and I was just thinking the same thing. Do you guys have any plans on moving into the 5.9 or primarily the 6 gigahertz now that it's wide open?
Yeah, so I wanted to ask about 6 gigahertz, but I also was curious about the upper and lower bounds of 5, so like 4.9 and 5.9, which are usually like the kind of the license, but still Wi-Fi.
Yeah, the 4.9 is licensed, and it's kind of its own mess right now. And so it's for public, it's for public safety, and so it was kind of carved out after 9/11, and so it's
is that still considered part of the WiMAX space? Because I thought WiMAX was like 2.5, and then
no, this is up at 4.9 gig.
Okay.
And so it was more your police and fire, but what was very interesting for us and a lot of our customer base is that your water wastewater qualified for that. So they could get a licensed high-speed network. And before you get too excited, Scott, it's kind of a FCC licensing quagmire right now. And so it should get resolved out there. But what was nice with them is one of the other things that you run into in the unlicensed band is even if you have a lot of signal, sometimes when it gets, in the case of an event, right, some sort of an emergency, everybody's on that and you can't get data through it. This way they stay completely off of all that, we'll call it duty cycle of those frequencies. But this is used not only for, your classic fire and police, which it's probably not the best frequency for that, but for water, wastewater. And then Department of Transportation uses it quite a bit. Anything that can be like that municipal or a state use, most of them will qualify for it. So they can have a completely isolated licensed network on there. And so,
and do you have devices that function in those?
Yeah, and it's our Horizon 4.9. So Horizon's just a family, and then the frequency bands. We've kind of looked into the 600 and some of the or 6 gig. We don't have any immediate plans to go down in there. Just because of most of what we get brought in for is really a lot of backhaul type stuff.
And
to
like
where
longer distance.
distance.
Yeah.
And so those are usually better served for more like enterprise. We're really looking for the higher speed. But once you stretch things out 5 miles, that kind of goes away. We'll never say never to anything, but it's really kind of like, we live in industrial automation. We don't get into the hospitals and hotels and some of that sort of thing. But we'll never say never.
Oh man. Well, we
How
have.
would you guys, hold on, Scott, how would you
No.
guys feel about, maybe there's an aluminum bodied vehicle that's out there that takes biometric fuel, and if you get it going 88 miles an hour, it can. No.
Well, we've looked at we've really looked into putting a flux capacitor into the new 6 gig.
Well, I was, because we were talking about looking at different frequencies, and I was wondering, if you guys were going to step into the 6 gigahertz arena, how many gigawatts were you going to have to put behind that to actually
Yeah.
power that properly?
Yeah, with Mr. Fusion, right?
Exactly. Well, and typically it's 1.21 gigawatts, to at least get your signal speed up to 88 mile an hour. So.
I think Eric has really been looking into this more, so I'm going to go ahead and allow him to answer this.
Great.
That's right. That's a perfect question to pawn off on him.
Yeah. Go ahead. Why don't you summarize that, Eric?
Yeah, we'll summarize it. All right.
Well, how can if people want to track you down and get a hold of you and ask you more questions, how can people get a hold of you guys?
Yeah, I mean, probably the easiest thing is just right off of the website, which is just esteem.com, esteem.com. It's got all of our contact stuff. You can, if you're old school, you can call us on the phone. You can email us. I don't know if you've got our emails that you're going to attach to this that we can put out as well. And then also, honestly, one of the things that's been one of the bigger things for us this year is we've just added a chat tool to the website. It's not AI driven. There's no bot. And so if you have a question, and it's taken off for us a lot more than we ever thought. And it's both on the sales side as well as support, that we can just hit this thing. And it's
So
really
it's
been
not like a generic Tim or Sharon.
Nope.
No,
you're going to see Eric's smiling face or mine or Perry's or Phil's, and you're going to be talking to us, and all the support is done here as well. And, it's pretty tough not to be able to get a hold of us, but if you just go through our website, it's got all the phone numbers, email it, we can go there. And that's both on the sales and the support side. And then there's the little tool, little pop-up that you can hit us with as well. And I can send you what the email addresses is for Eric and myself, for whoever else you might want to have.
That's awesome. Well, this whole discussion really has just quantified that Some people think that 900 megahertz is dead, and that is not the case. It is still incredibly useful, and is all, in my opinion, is only going to become even more useful over time. And I really appreciate you guys taking the time to come on and hang out with us and talk about all this stuff. I'm a 900 megahertz kind of junkie on the side anyway. So this episode has definitely been personal satisfaction for me. I've thoroughly enjoyed it. Thank you guys so much for coming on, and hopefully we can have you guys back sometime.
Oh,
Sounds great,
absolutely.
Scott.
It's been a pleasure.
Yeah, thanks a lot, Scott. Appreciate it.
Thanks for listening, everybody, and we hope you join us on our next episode of the Industrial Wi-Fi Shop.